हॅलो. एकच मिनिटात सुरू करूया.
ओके सर.
हॅलो. याचा आवाज कसा बंद करायचा? हॅलो. ओके.
ओके.
दोन मिनिटं, माझ्या थोडा इकडं दुसऱ्या डिव्हाइस वरचा आवाज बंद करायचा आहे, पण तो होईना झालाय. ओके. Good evening. I hope my voice is audible clearly. Still there is. We will be studying the basics of CNN for the deep learning. That's the today's topic. So I have searched a few contents from internet and we will go with that. So basically I will share here. So these are the cheat sheets. That means it is a kind of summary which we will be using for solving the or understanding of these problems. So what is CNN? And then we will use this sheet as well as some of the content from the internet so that we will understand. So convolution neural networks, which we are calling as a CNN, it's a little, it is basically based on the neural network which we have studied last time. If you recall our earlier lecture, so in that lecture we had understood the concept of neural network, where we had some input, some output, and then there were hidden layer. शिवभक्ती ऐकू येते का माझा आवाज?
Yes, sir. Clearly ऐकू येतंय.
ठीक आहे. So now we are extending same concept to the convolution neural network. So it is convolution neural network is one of the kind of type of neural network you can say, and this has become kind of foundation for the deep learning. And what is mean by convolution is when we have huge data, it's kind of algorithm for the abstraction. It is for algorithm for the abstraction of information. We are using the convolution neural network. So as mentioned earlier. So what are the components of convolution neural network? If you can see here, there will be, and mainly convolution neural networks are useful for image, because each pixel, let's assume today I have some annotation tools, so I will be doing some annotations also. So if you take, let's say 30 by 30 image, if you take some 30 by 30 image, so total how many pixels will be there? Around 900 pixels will be there. How many pixels? Around 900 pixels will be there. And if you have to pass these all these 900 pixels as an input, then you will need input nodes for the input layer. How many nodes required? We need 900 nodes. And imagine, usually we have images of the order of 200 by 200 to somewhere around typical images, and you can see the size of the network, or you can see the input layers required for the for so what kind of network is required, you can imagine. And that's where the importance of CNN will come, convolution neural. The convolution layer and pooling layer can be fine-tuned with reference to hyperparameter that are described next. So you can see in CNN what are the components we have to understand, and each of the term we will understand slowly. If this is given good in this network, it's fine. Otherwise, we will be using some other contents from the website. So if you see input layer is there, then there is a convolution, pooling, and fully connected. Three concepts we have to understand. One is convolutions, poolings, and fully connected. So we can see what is mean by convolution layer. So what are the different types of layer here? One is input layer, usually it is image layer. Next one is convolutions. It may not be one, there will be convolution, different convolution, 1, 2, 3, one after another. Then there will be pooling, or usually it is convolution, pooling, and the last layer which usually they call it as a fully connected layer. So we'll understand one by one what is meant by convolution, what is meant by pooling, and then maybe if required some hand calculations. It is important because all these things are readily available in TensorFlow and other Python modules. So what you need is the concept, mathematical concept and physical concept behind these whatever computer modules are there, and that's why we have to understand actual meaning of that. So what is convolution layer? The convolution layer uses filter that performs convolution operations as it is scanning the input I with reference to its dimension. So it is basically one filter which is abstracting the information. So let me jump on to other document, and we will do the calculation exactly what is mean by that. And it's a hyperparameter includes a filter and stride. The resulting output O is called as a feature map. So it will basically convert the way we had a physical feature maps earlier. For example, आपला चेहरा आहे. So in that, color is one feature map, eyes are another feature map, नाक कसा आहे, कान कसा आहे, डोळे कसा आहे, these were the physical feature map. Now we are using the filter, we are converting into different feature maps. So let me take the some kind of another document. So if you see, similar diagram is here. I will go and so this is the convolution step. So what is mean by convolution step? It is like a stamping on the existing image, stamping on the existing image and summarizing. It's something like a multiplication. Let me take one example. Okay, here I'll take. Okay, so we'll just give me 1 minute. Okay, here comes convolution layer. Hmm. Why this is not calculation I'm searching. Okay, I will show you here. I got one operation. Okay, here if we see, if this is our original image, on that if we are putting a some kind of filter, so we will keep on moving this layer by layer to the next layer. Suppose our filter is this one. So what is this filter? Has 10001, it's a 3 by 3 filter, and then we have 010100, and this in the these are some digits in the image. So we will understand how they come also. So what we have to do is we have to overlap this filter, multiply by these numbers, and get the total summation. So for example, here 1 into 1, 1 into 1 is equal to 1. Then 0 into 0 is 0, and then 0 into 1 is 1. Sorry, 0 into 1 is again 0. So the addition of multiplication of first this one is 1. Similarly, we will go second layer of image, sorry, second row of image and second row of filter. 0 into 1 is 0 again. 1 into 1 is 1, and 0 into 0 is 0. That's how you will get 1. Similarly, let's go to the third row of image and third row of filter. 1 into 1 is 1, plus 1 into 0 is 0, plus 1 into 1 is 1. So that will be 1 plus 0 plus 1 is 2. So and total addition will be 2 plus 1, that is 4. That's how you get the number, and this is called as a convolution process. So we have to understand what is there in the convolution process is we have some kind of filter, and we are moving that filter from one end to another end, and that's the process which will give you the another resulting number or another resulting figure like this. Let's go to the next point and understand what is meant by pooling. The pooling layer is a downsampling operation typically applied after convolution. Usually once this is done, we have to downsize, and that is applied usually after convolution layer, which does some special interventions. In particular, max and average pooling are the special kind of pooling. So there are two types of pooling. One is called as max pooling, and another is called as average pooling. So there is a next layer is called as pooling layer, and in that there are two ways. One is max pooling and another is average pooling. So we will understand the example here. This is a very good example available. What do we do in max pooling? If there are filter of 2 by 2 and stride 2 by 2. You understand what is meant by stride? uh, uh, First we'll understand filter 2 by 2 means we are selecting 2 by 2 matrix. Stride 2 by 2 means we are giving gap of 2. If it is 1 by 1, then horizontal we will run by 1, and so and vertically we will run by 1. Now here for simplicity we have taken 2 by 2 filter and 2 by 2. That means this 4 layer will move on here. So now in this max pooling, what are we doing is we have to take maximum value out of this 4. That will be 9. Then next, out of this 4, what is the maximum value? 7. Out of this, what is the maximum value? 8. And out of this, what is the maximum value? 6. And these are the result after the max pooling operation. So the first operation, जरासं थोडं ब्रेकमध्ये तुम्ही बोलू शकता, काय होतं पहिलं ऑपरेशन, कोण सांगेल? What was the first operation? जॉईन वेटिंग मध्ये काय टाकलं तर झूम वरती? नाही नाही, हा झूम टाकले बघ टीचरवर, टीचर्स. हॅलो, चलो. First operation was कोण सांगेल? अनम्यूट करा आणि बोला. येते का अनम्यूट करायला? What was before pooling? What was the operation? Convolution. Can you repeat? Everyone unmute and shout. First operation was convolution.
Operation.
बोला. परत एकदा इथं जातो. काय? कॉन्व्होल्युशन, पुलिंग आणि मग फुल्ली कनेक्टेड. सो प्लीज अनम्यूट टॉक so that I will understand you are participating. इज इट क्लिअर? कॉन्व्होल्युशन मध्ये काय करतो आपण? फिल्टर घेतो आणि फिल्टर वरून एक लेअर तयार होतो. पुढचं ऑपरेशन होतं पुलिंग. त्याच्यात दोन प्रकार आहेत. वन इज मॅक्स पुलिंग अँड द नेक्स्ट वन इज कॉल्ड ॲज average pulling. Next one is called as average pulling. So what are we doing in average pulling? As the word suggests, we will have to add these numbers together. For example, here if you can see, काय इथे average? 2 plus 2 4, 4 plus 4 8, 8 plus 9, how much? 17. 17 divided by 4, it will come as a 4.25. Similarly, can you do the second operation? This will be 7 plus 3, 10, 6 plus 1, 7. So that will be 17 by 4. And in this case, what will be the average pooling? 2 plus 2, 4, and this 10, that is 14 by 4. This is how you get the numbers in average pooling. You get the numbers in average pooling. Why these operations are required? Actually, we are creating some kind of bottlenecking. We had a big image. We are trying to reduce its size. Further, we are trying to reduce its size. What is the purpose of this? This process is called as some kind of abstraction. This process is called as some kind of abstraction. And you might be thinking, how are we getting this idea? How people might have got this idea is the way our biological operation happens, the way we do the abstraction in our brain. That's how it works. So you can see here in this Geeks for Geeks, you have like whatever these operations are there. For that, codes are also there, and that can be used for the learning and taking into the next level understanding of CNN. Okay, so let me come back. Next comes the, once after the this thing pooling layer, next comes the activation function. So last time we have seen activation function, role of activation function, etc. And that's the कोणते दोन ऍक्टिव्हेशन फंक्शन आपण म्हटलं होतं याच्यामध्ये लागतात डीप लर्निंग मध्ये? कोण सांगेल अनम्यूट करून? आठवत आहेत का दोन फंक्शनची नावं घेतली ती ऍक्टिव्हेशन फंक्शनची?
रेलू.
स्टुडंट सांगा. एक सांगितलं मॅडमनी.
tan h.
हा, टॅन एच होतं. व्हेरी गुड. पण ते आपण वापरत नाही डीप लर्निंग मध्ये. अजून कोणतं होतं?
Redu.
and redo. So let us read little bit about the activation function. So activation functions in neural network is a mathematical function that is applied to output for the neuron. It introduces non-linearity, enabling the model to learn and represent complex data pattern. Non-linearity representation, for the purpose of non-linearity, we are introducing this as an activation function. Already other parts we have studied. So there are linear activation functions and then non-linear activation functions. So we have last time seen sigmoidal, then tan H, then the ReLU. So mostly we need ReLU and leaky ReLU from the deep learning and CNN point of view. And that's why let's quickly understand what is mean by ReLU. ReLU stands for rectified linear unit function. So it is defined as a of x is equal to max of 0 comma x. म्हणजे once we pass the value of x to this function, त्याचं उत्तर काय येईल, आयदर 0 येईल किंवा x येईल. कशावरून, दोन्हीतलं मॅक्स. म्हणजे काय, कोण सांगेल मला, या रेलूला -2 इनपुट दिलं, x इज इक्वल टू -2 दिलं, तर व्हॉट विल बी आउटपुट. अनम्यूट करा आणि सांगा. ह्या छोट्या गोष्टी कळल्या पाहिजेत. नेक्स्ट लेक्चर पासून आपण थोडे कोडिंग कडे वळणार आहे. स्टुडंट्स प्लीज अनम्यूट अँड टॉक. इतका वेळ आपण रात्री बसलोय, थोडस पार्टिसिपेट केलं की. स्टुडंट टीचर्स पण आहेत बरेचसे. काय होईल -2 आत पाठवलं,
-2 to 2, -2 to 1.
नाही, एकच व्हॅल्यू येणार. मॅक्स ऑफ 0 इंटू x इथं दिलंय बघा, तुम्हाला दिसतंय का, काय मॅक्स ऑफ 0, x. मग आता काय येईल इथं
0
आपण,
to 2.
हा
0 to 2.
नाही, एकच व्हॅल्यू येणार. मॅक्स 2 मधला मॅक्स काढायचा. मॅक्स ऑफ काय काढायचा, 0,
हो.
-2. कोण मॅक्स आहे, 0 मॅक्स आहे की 2 मॅक्स, काय मॅक्स
0.
आहे, 0. म्हणजे आन्सर काय येणार, 0.
0.
कळालं का.
Yes, yes.
x इज इक्वल टू,
आम्ही त्यांच्याच बेकरीतून आणलं
x इज इक्वल टू 5 टाकलं तर ए ऑफ x काय येईल, ऍक्टिव्हेशन फंक्शनची व्हॅल्यू काय येईल, सांगा.
It is not visible clearly.
रेंज नसेल मॅडम तुम्हाला. x इज इक्वल टू 5 टाकलं तर मॅक्स ऑफ काय येणार,
5
0,
येईल ना?
5 म्हणजे आन्सर किती येणार,
5
5.
येणार.
कळालं का. सो दॅट्स हाऊ क्विकली वी विल अंडरस्टँड रेलू काय देतं, तर its range is 0 to infinity, meaning function only outputs non-negative values, and nature is, it is non-linear activation function allowing neural networks to learn complex pattern and making back propagation more efficient. And what are the advantages of over other activation function, ReLU is less computational expenses than the tan h and sigma d, so that's why computation becomes fast. आणि त्याचा प्लॉट तुम्हाला लक्षात येतोय का बघा, इकडं निगेटिव्हची किती व्हॅल्यू आली तर आन्सर काय येणार, 0 येणार. आणि पॉझिटिव्हची जर आपण 5 टाकली तर 5च येणार. इकडं पण, इकडं 7.5 टाकली तर उत्तर काय येणार, 7च येणार. सो दॅट इज द रेलू. लेट्स गो टू द नेक्स्ट फंक्शन दॅट इज कॉल्ड ॲज, सो कसं, नेक्स्ट फंक्शन इज leaky ReLU. What is mean by leaky ReLU? If x is greater than 0, answer is x. If x is greater than 0, answer is x. And if x is less than or equal to 0, answer is alpha x. Answer is alpha x. So leaky ReLU is similar to ReLU but allows small negative slope. म्हणजे काय, earlier negative slope was not allowed and now in leaky ReLU what is, मग कशासाठी हे समजायची गरज आहे की कुठलं ऍक्टिव्हेशन फंक्शन, इफ यू अंडरस्टँड दॅट इफ युअर output is non-negative, if your output is non-negative, then we have to use, हे अंडरस्टँड करणं गरजेचं आहे की इंटरनल पॅरामीटर कसे सिलेक्ट करायचे. इफ युअर आउटपुट इज नॉन निगेटिव्ह देन वी हॅव टू स्ट्रिक्टली यूज द ऍक्टिव्हेशन फंक्शन्स ॲज अ ReLU. इफ युअर आउटपुट्स आर like sorry, if you are in outputs you want like negative also, and that will be again with reference to some kind of small negative slope instead of 0. थोडंसं निगेटिव्ह व्हॅल्यूज पण टॉलरेट करायचे असतील तर तुम्हाला काय घ्यायचं आहे की लिकी रेलू घ्यायचं आहे. सो दॅट्स हाऊ यू कॅन टेक हिअर. म्हणजे काय असतं याच्यामध्ये, तर सिमिलर टू अर्लियर वन. सो थोडंसं आपण एक घेतलं तर काय होईल इथं, एफ ऑफ एक्स कुड बी एक्स, आणि आपण अल्फाची व्हॅल्यू काहीतरी घेतली 0.1 x घेतली. अशी घेतली. म्हणजे काय होणार, जर मी x -10 दिलं तर माझा f ऑफ x काय येईल, -1. इफ -100 दिला तर हा -10 येणार. तेच उलट केलं मी. इफ x ची व्हॅल्यू, इफ आय गिव्ह x व्हॅल्यू ॲज अ 100, f of x will be of course directly 100. So that's how it works. Chalo, we will go to the next point. Similarly, there are other activation functions. There are exponential linear units. These are also important. We have to understand softmax function, and then there is a soft plus function. Usually softmax functions are also required sometimes. So let's understand what is meant by softmax function. Softmax function is designed to handle multi-class classification. ज्या वेळेला शेवटचा लेयर आपल्याला क्लास वगैरे काढायचा असतो त्यावेळेला आपलं ऍक्टिव्हेशन फंक्शन काय येतं, softmax. What is meant by softmax? We are taking probabilities of different outcomes, and out of that whichever is maximum we are shooting. So quickly we will read it. Transform raw output score from neural networks into probabilities. Correct. So it will, softmax functionचा काय फायदा असतो की it transform the raw output scores from the neural network into probability. कशासाठी लागतं तर क्लासिफिकेशनचा जो प्रॉब्लेम असतो, तुमचा पर्टिक्युलर क्लास शेवटी द्यायचा असतो, तर त्याच्या प्रत्येक शेवटचे नोड जितके क्लास आहेत तेवढे नोड ठेवले जातात. वॉट एव्हर नंबर ऑफ क्लासेस आर देअर, दॅट मेनी नोड्स आर मेड अवेलेबल ॲज अ फायनल आउटकम, अँड देन out of that, so usually the outcome will be between 0 to 1, and then ensuring sum is equal to 1. And softmax is non-linear activation function. Softmax function ensure each class is assigned probability, helping to identify which class means पर्टिक्युलर, म्हणजे ज्याची प्रोबॅबिलिटी जास्त आहे तो जो क्लास आहे तो आपण फायनली आन्सर म्हणून घेतो. दॅट्स हाऊ क्लासिफिकेशन प्रॉब्लेम विदाउट अप्लाइंग फायनल क्लासिफिकेशन आपण डीप लर्निंग last layer can be given as a softmax activation function so that it can become a classification algorithm. Then comes something called as a fully connected layer. मगा जो बघितला आपण लास्ट वाला होता तो काय होता इथं, last one is after pooling there is a fully connected layer. So what is mean by fully connected layer? These are responsible for making predictions based on high level feature levels by the previous layer, and they connect every neuron in one layer to every neuron in the next layer. So all the connections are formed from the previous layer. So we can see how the diagram looks like. So this is the previous layer, this is dense layer, and what is there in the fully connected? It has connected to each layer. So why this what are the different components of this layer? A fully connected layer is characterized by its dense interconnectivity, hence broke down into key component: neurons, weights, biases, activation functions, that already we have studied. And then it finally helps in feature integration and abstraction. It helps in decision making and output generation, and it introduces the non-linearity to get the final answer. That's how it works. So quickly we will recap. So we have seen the first one is convolution. Here what are we doing? We are selecting particular filter and we are moving those filter by some value that is called as stride. Stride will be usually 1 by 1 or 2 by 2. What is mean by 1 by 1? Horizontally it moves by 1, vertically also it moves by 1. Next comes pooling. There are two types of pooling. One is max pooling and average pooling. Max pooling and average pooling. So we have seen max pooling means what? We select maximum number of out of that. And what is mean by average? We are doing the average of what you call numbers in that boxes. Next, the last layer that is called as the fully connected layer. It operates on a flattened input where each input is connected to all neuron. If present, the FC layers are usually found towards the ends. आणि मग हे कुठं असतात? They are usually towards end of the network of the CNN architecture and can be used to optimize objective such as class score. So you can see that in some of the hidden layers are not fully connected, but towards the end we cannot keep like this. When we will see the architectures of different types, maybe next lecture or so, we will understand that this architecture design, some layers are connected and some of the layers are not connected, and that's how this important thing is that connection is required. Next, we have also seen the filters here. So this filter size selection is also important. Usually filter size is f by f. It is in 2 dimension. What is mean by 3 dimension? If RGB image is there, that means your size will be, let's say, 3 by 3 by 3 into 3. Okay, that's how filters works. What is meant by stride? For a convolution or pulling action, the stride denotes the number of pixels by which window moves. So here you can see हा जो फिल्टर आहे किती विंडोनं पुढे सरकेल. Is it by 1, is it by 2? And then strides are vertical and horizontal. Next comes padding. So it is very important. There is a next operation is called as padding. Usually when we have to keep the, तुम्हाला हे एकदा ह्या टर्म लक्षात आलं की in your Python you will have to use 2 types of padding, either same or full. Okay, so zero padding denotes the process of adding p zeros to each side of the boundaries of input. This value can either be manually specified or automatically set, one of these 3 modes detailed below. So you can see that padding, usually the numbers are added as a zeros, but you can add some other numbers also. And in this case, we can have 2 options. One is called as a same, another is a full. So, and this purpose we will understand what is the purpose of padding for keeping. You have seen in the convolution process and in case of what you call max pooling and average pooling, size of images gets reduced. But sometimes when we want to keep the size of image as the same, the other numbers we can keep it as a 0 only. Other numbers we can keep it as a 0. So this is what we have to understand as a basic parameters. We have also covered the activation function used in the CNN. This is ReLU, leaky ReLU, and then there is a ELU. And then we have also understood what is meant by softmax. So softmax are step where we are calculating the probabilities. We are calculating the probabilities, and then comes what are the problems. We have seen the image classification, detection, localization. New part, one more thing what we have seen, one pix to pix classification, regression and prediction we told. कुठले कुठले प्रॉब्लेम सांगितले होते आपण? कॅन यू रिपीट? पिक्स टू पिक्स, क्लासिफिकेशन, रिग्रेशन अँड प्रिडिक्शन. कॅन यू रिपीट? कुठले प्रॉब्लेम सोडवतो आपण CNN नी? अनम्यूट अँड रिपीट. चला किती जण
Pix to
बोल.
pix regression and classification
अजून एक राहिला, प्रिडिक्शन.
prediction.
प्रिडिक्शन And then one more problem I have understood, that is localization. This is also important. So this is like a image classification, not only classifying, but in a big image, where is that particular image, that finding is called as kind of localization. Okay, so these are the different types of problems, and quickly I will come back. So what are the uh, other terminologies remaining? Today I wanted to cover the basically terminologies. There are different models, I will not cover that. So we have 5 to 10 minutes. Last that part I will cover, that is here in the tips and tricks we will see that. Okay. So we have also understood something called as data in how to increase the data. Last time we have seen, if original image is there, we are flipping, rotating, random crop, color shift, noise addition, information loss, and contrast, that we can do, and that process is called as data augmentation. Next is, आता कुठल्या कुठल्या प्रोसेसेस आहेत बघा. बिफोर वी सेंड टू द CNN, first we have to, if we have to increase the amount of images, then we can do the data augmentation. Next is batch normalization. It is the step of hyperparameter gamma beta that normalizes a batch by noting the mean and variance of that. So we want to correct the batch. It is done as follows. So what are we doing is, we are doing the batch normalization by taking the mean, variance, etc. So it is usually done after fully connected convolution layer and before non-linearity layer, aims at allowing higher learning rate and reducing the strong dependent on the initialization. So once you do the batch normalization, it helps in learning properly. So let's understand a little bit more about the batch normalization. So what is meant by batch normalization? So batch normalization is a deep learning technique that stabilizes and speeds up training by normalizing layer inputs each mini batch, reducing the interval coherence shift, changing input distribution, and allowing higher learning rates, deeper network, and better generalization, often acting as a regularizer. So we are kind of selecting different batches and normalizing, and that helps in kind of proper learning or improving the learning curve. Next term is training the neural network. There are few terms which some of which we have already studied, like loss function, cross entropy loss, and back propagation. Last time we have studied in the neural network. So one of the important term, that is called as epoch, and how to select the epoch, that we have to understand. Okay. So what is mean by epoch? In machine learning, epoch refers to one complete pass through the entire training data set, where every data sample is passed through model and its parameters are updated based on calculated layer. So what is mean by that? If I have a data of 1,000 images, so if I make each batch of, let's say, 100, so I will calculate the error for all these 100 images. So what is mean by that? Let me quickly take simple calculation here. Suppose we have 10 inputs, x versus y, 1 2 3 4 5 6 7 8 and 9 and 10, and accordingly I have some 2, 4, 6, 8, 10, 12, 14, 16, 18, and 10. Now, sorry, 20. Instead of using all this data together, I can make a two batches, one this and another this, because sometimes training using complete data may be computationally costly. So what is mean by that? So I will be calculating the final value y for summation, or what do you call it, error, not final value. So maybe we call it as a error. So I will have error 1, I can say, will be summation of 1 to 5 and yp of I minus y actual of I square, let's say RMS. Similarly, I can do it for the error 2, second batch. So I can get this batch, or whatever updated weights are there from previous batch, I will pass on to next batch and I will find out error. And likewise, this process, instead of using the data as a complete data together, we are using the batch wise. The training process requires multiple epochs, allowing the model to improve iteratively by adjusting the parameters. So here is the example, whatever I was telling. For example, if training data set has a 1000 sample, one epoch would involve the processing and updating of model with all 1000, that's one process. If data set has a 10,000 sample but batch size is 100 used, then there would be only 10 batches total, and in this case each epoch would consist of 10 iterations, with each iteration possessing one batch of 100. So this is how epoch and batch relation is there, epoch and batch relation. So you can see here, if batch size is 10,000, iteration per epoch is 1. If iteration per epoch, if there are 5 batches, then iteration per epochs are 200, and if batch sizes, 10 batches are made, then what will be there, iterations per epochs are 100 typically. So how to select, we will see. So typically when training a model, the number of epochs is set to large number like 100, and then early stopping method is used to determine when to stop training, and this means model will continue to train until either the validation loss stops improving, maximum number of epochs is reached. So this is how like we have to take judgment based on the what are the datas and etc. So this is important part. Apart from selecting the batch size and epochs, we have to also select the learning rate, then learning rate decay. These are the parameters for the optimization we have to select. I guess I have covered most of the parameters: mini batch, loss function, cross function, back propagation. Already I told you this. So we have to understand the other parameter alpha, etc. What was there? It was related to your Adams optimization, and in that there is a these are the parameters. One is momentum and RMS prop, etc. I guess I have covered all the basic parameters. So before I close, quickly I will show you the what we will be covering next lecture, and then so in the next lecture we will start taking the tutorials for different applications, and in that we will be taking actual example, whatever classification etc. We'll be taking simple examples. So using the collab, Google Colab. So while attending the next lecture, you should have like mobile as well as laptop so that you can see in the mobile and operate it on the Google Colab. So I guess that's it from my side. See you maybe next week sometimes. Thank you. Chalo, good night. आहेत का सगळे गेले?